Hello guys, welcome back to Maison African Motives, still on our MECHANOTECHNICS N5, working on the introduction, talking about the epicyclic gear trains in this case. So we need actually to know the basics that we are going to work with to explain the basic working principle of an epicyclic gear system. To explain the speed increases with the sun gear or annular stationary, speed increase with annular stationary, speed reduction with sun gear stationary. So like what is going to happen if one is fixed, that is being stationary, there's no movement. One is fixed, another one is increasing in terms of speed, another one is stationary, another one decreasing in terms of speed. So these are some of things that we shall be considering. So what you actually need there is also to understand the applications that you're going to be playing around of the epicyclic gear train, whereby you need to know the components that is made of the planet gear, which is the planetary gear, the sun gear, the arm, and we also have the ring gear, which we also refer this as the annulus, the one that is on the outer part of our gear system. So these are the components that you're going to be working with. So we are simply saying the epicyclic gear train is used extensively due to its many benefits and applications. As mentioned, it has three main components. So these are the major components. That is the sun gear, one or more planetary gears. So like we can see, we've got 1, 2, 3. So it can be 2, it can be 1, but it can be 1 or more. And also we talk about the ring or the annulus gear. An epicyclic gear can be either a simple or a compound. We can have this combined together. A lot of things that we can consider later on. And also we need to consider that the section below discusses the application and uses of the epicyclic gear trains, as well as the advantages and disadvantages of an epicyclic gear. In this case, we talk about the gear ratios. You just need to know actually like what's happening in terms of the increase in torque when you're dealing with the calculations. You can even check on your calculations to see is it increasing or decreasing. All right, so this one we are not going to focus much on it, but what you need also in your syllabus is to understand the advantages. They might ask you advantages and also the disadvantages. So epicyclic gear trains are popular for automatic transmission in automobiles. They are also used in bicycles for controlling pedaling power automatically or manually. They are also used in the back gears and of lattice hoists, pulley blocks, and also the wristwatches. So there are so many things that you can consider as your advantages. And the disadvantages now, it's a complex design that you are working with due to the many interacting parts requiring precise tolerances. So on that condition, it becomes so disadvantageous, and other ones that you're going to consider on your calculations and so forth. Then some of these things here, calculations of simple epicyclic gear trains. To do calculations involving epicyclic gear trains design, you need information regarding the input and output shaft speeds, often measured in revs per minute, and torques that are involved. You can then calculate the correct gear sizes and also the number of gear teeth required. So you can talk about the gear size required for gear reduction and so forth. And if you're dealing with any rotation that is going to happen, a full rotation, it happens at 360 degrees. And also on your rotation, any rotation that is in the clockwise becomes a positive. Any rotation in the anti-clockwise is taken as a negative. So a complete revolution, one revolution is equivalent to 360 degrees. We are considering to say it has completed a revolution. All right, so those are some of the things that you shall consider, and also the indication of your number of teeth, and also TA for the number of teeth on the annulus, the planetary, the sun gear, this T is for the number of what? The number of teeth on the annulus, the sun, and so forth. For the speed, we are going to use N, NA, NS, NL for the annulus, for the sun gear, for the arm, in this case, if you're dealing with the arm. So the planetary, we do not consider the speed. We are not going to consider that part. We shall see on our calculations and so forth. So I talked about the issue of our rotation being positive and negative. So these are the stages that you're going to need on your table. All right, let me try to increase so that you can see properly. The first part is our rotation. Like I said, if we are to rotate the entire gearbox a number of times in positive direction, treat the clockwise as positive, anti-clockwise as a negative. Then also, what you're going to do is that you are going to fix the arm so that the epicyclic gear train functions in the same way as the spar gear meshing. This allows you to obtain a relevant gear ratio between the three gears. Remember that the first condition relates to the gear ratio and has nothing to do with the speeds involved. I always explain to say, when you are the information, it's a fixed issue. You do not involve any part of your question that you are given there. So that is what you're going to have. And also when the annulus is rotated in clockwise, the planetary wheels rotate the same direction since the annulus is ringed. So take note, the annulus and the planetary wheels, they rotate in the same direction. For the sun gear to move, the annulus must drive the planetary. So take note. For the sun gear to move, this annulus must drive the planetary gear so that they drive the sun gear in an anti-clockwise rotation. So the sun gear is going to be in an anti-clockwise rotation. So what does it mean? It means that the teeth on the annulus now, remember, over the teeth of the planetary is going to be positive, depending with the condition that you're dealing with. It's going to be TA over TP. But considering now what we had before, because we are saying here for the sun gear to move, the annulus must drive the planet, which means we are supposed to start by first the annulus versus the planetary. Then we talk about itself, its own combination of the sun gear and the planetary. But the sun gear, it must be in the anti-clockwise for it to have it. So that's why we end up with the minus. So this is a stage that we are going to see involving on our table. Then we shall have a condition now whereby you are supposed to multiply by X the values that you get and add Y on whatever ratio that you obtained before. Then the last part now is on the stages that you are given. This is something that you are now given from your exam question. This is the stage that you're going to involve depending with the speeds that you're given. So the further step is used to find the unknown rotational speeds between the annulus NA, the sun gear NS, and the arm NL, where two speeds need to be known in order to solve the simultaneous equation. So you need two speeds to be known. When using this method, you use the step 3 and 4 for calculation. However, step 2 is a vital as the other steps, because once the gear rotation is miscalculated, it can have a ripple effect on the remaining steps and lead to incorrect end results. So we are going to take from these values that we are multiplying by X, we equate to this information that you'll be given. We shall see that one later on our table. So these are some of the things that you can note and so forth. The speed ratio increases as torque. When you talk about the torque now, we shall have that one on a separate class whereby we'll be explaining. Then on your table now, which is the table of calculation, that is our table of motions in this case. This is how it is going to look like always, all right? We are going to have the number that is considering what you are given there. Sometimes it can be up to 4 stages, all right? Then the condition, as we saw that the first condition and the second condition, these ones, you are supposed to know them by heart. Always, we said we fix the arm from those notes that I had. We said we are going to fix the arm and we rotate the bigger the bigger wheel in this case, the bigger one, which is the annulus. So you rotate the annulus gear in this case. Then the other ratios, we talked about this from that table, and also how you calculate what is affecting on S. So if you are to consider on a normal condition, you see that this part here is the same. TP and TP is the same. So this will cancel. So at the end, you see that when we are talking about gear P, we are considering what A is doing, the one that rotates over P. So it's going to be TA over TP. You're going to see TA over TP. Then you consider the direction. On gear S, we are going to see we are going to remain with the same thing, TA over the one that you are calculating its value, which is TS. But consider the direction, which is a negative because of the anti-clockwise. The arm is fixed. The arm is fixed, so there's no movement. That's why we are having a 0. Whilst plus 1 revolution, because we are considering A is the one that we are considering here. So it's supposed to be TA over TA. So as you can see, this one and this one, it just gives us a 1. So everything is A from TA over A, P, TA over P, S, TA over S. That's how we're going to end up with as we are going. So whatever that you get here, you multiply to X, you add Y. Whatever that you get, you multiply X, you get Y, A, you add Y, and so on and so on. Then this is the one that I said it is taken from your question. That's why I said this step is dependent on the question posed, the question given from your question paper. That is the one that is dependent on this one. It's not from like something that you're supposed to take to say this one is going to be like this. No, you take from what you're given. So you use whatever that you're given, but you are supposed to have at least this or this to calculate this, or you are supposed to have this and this to calculate this one, or you can have this one and this one to depending what you're given. You use the question now that you are given on the final part, the one that you be given on your question paper. So that's how we relate these calculations and so forth. So we shall see typical question like this one that we are having. And also to note, before we talk about this question, there are some calculations that you also need to know about calculating the number of teeth, and also some of these things like let's say we want to calculate the number of teeth in this case. Remember that the module is equal to the pitch center diameter over the number of teeth, Let me just use T for the number of teeth. So meaning to say, to calculate the number of teeth, I can make this the subject, meaning to say T is equal to PCD over the module in this case. That is what you're going to have, pitch center diameter over the module. And also to calculate the number of teeth on the annulus, we are going to use the formula that TA is equal to TS plus 2TP. That is the number of teeth on the annulus, which is our ring gear, is equal to TS, which is the sun gear, plus 2TP, which is the planetary gear in this case. This formula you're also given in the formula sheet. So it depends with which formula to use between these two to calculate. Sometimes, since we saw that on the table, you're supposed to have at least the information that corresponds to the question. So if you are not having that, or sometimes they might ask you to calculate the number of teeth, whereby it's not about the table or it's not about what, that is where we can consider this formula. I think with this information, we can be able to answer any question that we have from our N5 staff. This is what is important, and also adding what you had from your N4. So this is what we have here. We're given a simple epicyclic gear train calculations. All right, so this is a simple epicyclic gear train that we are going to consider, having a compound gear D, the internal gear at G, the arm and E, and C in this case B. So on the information that we are given here, we are given that Fig 5.13 is a simple epicyclic gear consisting of a sun gear and 3 other gears in this case. Refer to Fig 5.13, which shows which shows a simple epicyclic gear train consisting of a sun gear the three other gears, the ring gear, which is G. So G is representing the ring gear, which is the annulus in this case from this part here. This G is the one, this G is the same as this G that we see, which is our annulus in this case. So here, remember, we have got our ring gear or the annulus in this case, which is the outer part of our gear in this case. All right, then we also talk about the arm. In this case, we talk about the arm. So the arm, we use it at the end. This is at the end, which is B. So we are going to consider as arm B. Then C being our sun. All right, so we have got the sun gear in this case at C. All right, then we have got the planetary gear in this case, which is E. So this E, which is this one, that is, remember, it's is the annulus. Then we have got the planetary in contact with the annulus. So this one that is in contact with what the annulus is our planet gear, which is the planetary in this case. So we have got the planetary gear, which is the E in this case, that is our planetary. Then the one that is inside, just in our D in this case, which is in line. So this one is an inline gear that we are going to have, since here it's having as a compound gear. So this gear D is in line with the gear E, it's compounded together. So meaning to say they're at the same speed. These two, they are at the same condition. We are going to consider this at the same condition. So D and E, in this case, D and E, which is the planetary gear, are compounded. These are compounded. So meaning to say same conditions apply, same conditions apply, same conditions. All right. So that is what we have there. Let us see what we are given. So the information here is fine. Just consider the number of teeth that we have, if everything is there, and so forth and so forth. But our question here was to calculate the speed and this, then also the output shaft speed, assuming. So this, like we said, is the information that is from the question. This is the last information here. This is the on your table here. This is the last information from the question. The first stage, the second stage, these two, they are fixed. They do not change. You always fix the arm, you rotate the annulus. In this case, our annulus is given by what? Our annulus is given by what? By B in this case. All right, our annulus is what? It's G. So we are going to rotate G one revolution. That is the first condition. So I'm just gonna have my table. Let us just try to have our table. If I have it down here, I just hope it is going to be clear. Let's just hope it's gonna be clear. So here I'm going to have a table. So let me draw the table first, then we can be together after the table. All right, so this is what I'm having now at the end. So the reason why this one is having a lot, let us consider here. Remember, we are supposed to have our number, then the condition. All right, so let us just have our condition. I want us to see why we've got a lot. In this case, we are supposed to work with the annulus in this case, which is the ring here, which is G, going to the planetary, which is E. But as you can see, E is having D. So there is 1, 2, 3, and also for the sun gear, and also the arm is also involved. So you're going to have 1, 2, 3, 4, 5. That's why you see here I've got 5 conditions here that I'm gonna have 1, 2, 3, 4, 5, which is 1 for the gear G, which is our annulus in this case. Then we've got gear E, which is the planetary in this case. Then we have got gear D, the one that we said it's in line, compounded to E. Then we have got gear C. All right, there was a gear C, which is the sun, and we also have the arm. So we are going to consider the arm in this case. All right, why am I taking this part? Let us take on our information. It's working on the output, in this case of the arm. The arm is connected to the output shaft B. So we are dealing with the output shaft, in this case, the output shaft of it, which is B. So here we are going to consider the arm at B, because someone will be wondering to say, why are we not considering the input A? We are going to consider B as the output, the one that we are given there. All right, so these are the conditions. This is our table that you're going to have. And remember, the first thing, as we said, it's going to be something that is not from the information or so forth. You need to know it's a fixed thing. You fix the arm, then you rotate the annulus. So meaning to say, in this case, our arm is referred as B. So we are going to fix B in this case. So fix the arm B in this case. What do we do after that? We rotate the annulus. Remember, G is our annulus in this case. This is our annulus. So we are going to rotate G in this case, which is the annulus. 1 revolution clockwise. So that's +1. 1 revolution clockwise, that's a +1. So now let's consider what's gonna happen between G. Like I said, if you consider G, it's going to be what is rotated, G over G. So G is just gonna remain with a +1. For E, it's going to be G over E. For D, it's gonna be G, but D and E are connected. So this one is going to be the driven. Let's consider E and G, even if you have to consider on your diagram here, G and E. So it's gonna be G going in the clockwise, the planetary also in the clockwise. So the G clockwise, the planetary clockwise. So we are going to have this as positive in this case, all right? So we are going to have this as positive TG over TE, all right, which is going to be our TG. All right, from the number of teeth we are given, I did not list these ones. Let us have, all right, let us have here from our information. This is what we are given. G has got 60 teeth. So TG, it's 60. The planetary gear E, 20. So TE, it's 20. Gear D is 24. So we have got TD, which is 24. The sun gear 16, TC it's 16. All right, is connected. All right, so these are the speeds that we are given at the end. So here we are working with the number of teeth only. So we are going to have TA over TE. Our TA, remember, it's 60 over TE. Our TE is 20. So this is going to give us what? A 3. All right, but remember about D and E, these are compounded together, connected. So they have same conditions. They are going to apply same conditions. So meaning to say here, we are going to have the same condition like the previous part. We are supposed to actually have this as a T. We are supposed to have it as a TG over TD, but here they are compounded together. So we are going to have the same answer, 60 over 30. So that is equivalent to what, to E. But now if you consider to C, let us consider what is happening with the C, which is our sun gear in this case. C, if we take note, we said in order for the sun to have a consideration in this case, for the ring to have a considered, it starts from the sun gear. So meaning to say the previous condition that we had between the ring gear and the planetary is going to maintain as it is. Remember, we said it's going to be TG, the annulus, which is the ring gear, over the planetary, which is TE. But now in connection, because it's affected also by C, but this C is no longer affected by E. If we take note here, the C is now having a contact with the D. C is having a contact with the D. So meaning to say, as the C is going in the anti-clockwise, what's going to happen with the D? D is going to in the clockwise, just like what the planetary is doing. But now we are considering the ones that are in contact. So we are going to multiply TC over TD in this case. All right, sorry, the driven. So the one that is driven is D. So D is the one that is driven. So it's going to be TD over the driver. It's now the sun, which is TC. But TC is going anti-clockwise. So it's going to carry a a negative. So if you check note, there is no cancelling this time because we are considering not TE. TE is not connected to, it's in connection with D. So be careful now on this condition that we have here. So meaning to say we are going to have TG over TE times TD over minus TC. So that is the condition that we are going to have here. So we are going to have TG over TE, the previous one, times TD. We said we're going to have TD over minus TC. In normal cases, you see TET where these two cancel. No. This time it's not like that. But the values that we are taking is the same because this is the one that we got. And remember what we said before, these two, they are just the same. So we are simply going to take the answer that we got previously, which is TG 60 over 20. It gave us 3. So it's going to be 3 times TD over minus TC. So remember TD, we have everything here. TD, that's 24. So we are going to have 24 there. So it's going to be 24 over TC, which is negative TC. TC is 16. So it's going to be negative 16. So that is going to give us minus 4,5. All right, so here we are going to obtain minus 4,5. All right, so that is how you play around. Let's move on to the arm. The arm is fixed. Fix the arm. The arm is fixed, so there's no movement there. It's a 0 there. There's no rotation that is going to take place. So that is what you're going to have. Then we move the second condition where we said we are going to multiply by x, add y. These are the ones that are fixed stages here. Multiply by x, you add y. So what we got here, we multiply by x, we add y. What we got, we multiply by x, we add y. What we got here, we multiply by x, we add y. That is what this stage simply indicates or simply means. So meaning to say here, we are going to have this as multiply by x, multiply by x, add y in this case. So this value here, you multiply it to x. So it's 1 times x, which is x plus y. This value, you multiply it to x 3 times x. So 3 times x, that is going to give us 3x. Whatever that we get, we add y. The same with this one, 3 times x is going to be 3x. Whatever that we get, we add a y. The same with this value, you multiply it to x, this value. So if you multiply minus 4,5 to x is going to be minus 4,5x. Whatever that you get, you add a y. The same with this one, you multiply by x, so it's 0 times x, that's a 0, guys. Whatever that you get there, you add y. So 0 plus y, that is going to be a y in this case. This is where your information ends. What you need or what you ought to understand, that is where it ends. So this part we do, the reason that I'm having this third stage and the fourth stage is because on our question here, we are given 2 questions at the same time. In actual sense, we're supposed to consider first question separately. We move on to second question, but on this case, let us just consider everything on the table, but we use information on item 1 to calculate what is corresponding to item 1. So let us consider the speeds that we are given. Already, there are some speeds that we are given on top here. We are given the input shaft A is connected to the sun gear rotating at the gear C. It's rotating at what? It's rotating at 120 clockwise direction, which is a positive. So already here we are given the speed of C, which is plus 120 clockwise, which is plus 120 revs per minute. All right, revs per minute. That is what we are given only on this part. Then D, all right, that is D fixed and the arm and so forth. All right, now our question is, let us consider our question and the speeds that we are given. Use this information to calculate the speed and direction of the annulus G, meaning to say we do not know the speed of G. So this is what we are going to do. We do not know the speed of G in this case. We do not know the speed of G. But given what? Given that the arm connected to the output shaft is fixed. Take note, guys, what we are given here. If the arm connected to the output shaft B is fixed, at that moment the arm is fixed, and the arm in this case is B here. So if the arm is fixed, it means its speed is at 0, it's fixed. There's just like what we had on the first condition, the arm was fixed, its speed, there's no movement, there's no what. So it will be at 0 revs per minute. All right. Then we also have this one that we are already given its information. So there's nothing that we're gonna do. We're just going to take as it is the speed of C. So that one we are already given. The speed of C is given as plus 120. That's 120 revs per minute. Already we are given this, so we are going to consider it. So this is a condition that you take from the question, from your question. You work it from the question. So that is from the question one. All right, so from question one, let us substitute NG. That is the one that we are supposed to calculate the speed at G. We do not know this speed. What about E? We do not have any information. Also about D, we do not have anything yet. C is at 120. C is at 120. Whilst the arm we have its information. The arm, we are told that at that moment, the arm is fixed. There's no movement about the arm. That is from question number one. So in actual sense, you're supposed to end there. You calculate the speed at G, you are done. You move on now, you go back, you calculate the one for the item 2, but let us consider these two items at the same time. At item 2, what are we given on question number 2? Question number 2, they are saying, we are supposed to calculate the output shaft speed. Remember, the output shaft speed is B. The output shaft is B. The output shaft B. So means that they are saying calculate the speed of B. This time, you are calculating the speed of B this time. So you are considering like you were never having the speed of B before. It's another question that you are given. So now we are saying we do not know this time. Okay, this is the fourth part of our table here. All right. So we are saying we do not know the speed at B this time. Given what? What are we given? We are now given that this time the ring gear is fixed. Now the ring gear is fixed. And what is representing the ring gear? The ring gear is our annulus, which is G. So they are saying G is fixed. If G is fixed, what does it mean? It means there is no movement at G. So the speed for G is now at 0 revs per minute. That is a condition that they gave you. You work with what you are given, and the question needs us to calculate the speed of B, but I said C, it's fixed. This one, C is not changing. That one, it's not given about, it's here, which it's a fixed information that we know about C. So C is at 120. So we are going to have our C at plus 120 revs per minute. Do not forget this part. So C is fixed at 120. So here C is at 120. Let me just try to indicate it like this. C, it's at 120 revs per minute. So that is it. So meaning to say, our question needs us to calculate what? NB, the speed for B, the speed of the arm. This is the one that we are supposed to calculate. We do not know this value. Given what? The speed for G, G is at 0, whilst C is at 120. C, as we saw this one. We do not have any info about this, any info. So that is the idea. So we want to answer question by question. Yes, guys, do not confuse. Please do not confuse here. I said there are two questions here. There are two questions. These are the questions that are given here. The first one, they said, we are supposed to calculate the speed and direction of the annulus G, whilst the output shaft is fixed. So this is the condition that we used here. But C, we already have its information. That is why we have to include it. The second question is to calculate the output shaft, which means we are talking about B in this case, assuming that the ring gear is fixed, whereby we said now G is fixed. This was the condition that we had here on the second part. So to answer the first question, what we are going to do is to equate to the first question. The first question, in this case, our first question, this is the information about the first question, this one. This is the information about the first question. So you equate to this information. This is what we have. So meaning to say on the first question, we are supposed to calculate NG in this case. We are supposed to calculate NG. So we do not know NG. So we are going to equate now. Remember, where you multiplied and added, this is where you take, we are going to equate this to NG. So we are simply saying X plus Y is equal to NG. Here there is nothing to equate. Here there is nothing to equate. We move on to this part here. Minus 4,5x plus y is equal to what? Is equal to 120. We equate y to 0. Y at that moment is equal to 0. So that's it. You have formed equation. That is for the first part. Move to end there. The second question is this one. You are going to form equations pertaining the second question. Now you want to answer the first question. So let us find the speed at g. So in order for you to find the speed of g, you need to calculate x, you need also to calculate y. Where are you going to calculate x and y? From these two equations that we are given. But already we are saying y is equal to 0. So we are simply going to substitute y, which is 0 here. So we remain with minus 4,5x plus 0, which is a 0, which is equal to 120. Find x, divide by minus 4,5 minus 4,5. So our x is going to end up as minus 80 over 3, which is minus 26,667. So this is the value of x. So now we are saying the speed of g here, according to our formula, it's x plus y. So meaning to say, therefore, the speed of g is going to be x plus y from this part, whereby x is minus 26,667 plus y. Remember, y is 0. So if we add y, if we add 0 there, we are going to remain with the negative. So therefore, the speed of g is going to be minus 26,667 revs per minute. What does it mean? It means 26,667 revs per minute in the anti-clockwise, if you want to write in words, but you can leave it like that. So we have solved question number 1 on this part. We used the information on question number 1 to answer question number 1, this one. We have answered question 1. Question 2, to calculate the output of shaft of B, we use the information that we related to question 2. Remember, this was the information about question 2, this one. About question 2, this is the information that we have here. This information is the one that you are going to relate to now. So what are we saying? We are saying this x plus y, it is now equal. We are equating down to the question, to the information about question 2. We are equating to the information about question 2. That is where we are equating our values to this time. We are taking them back to the information that corresponds to question 2. So meaning to say, we are going to have our equations now. So this is question 2. So question 2, we are going to form equation x plus y is equal to, or what are we calculating on question 2? We are calculating the speed of B, remember. We are calculating the speed of B. We do not know this. But we are given that x plus y is equal to 0. That's an equation. X plus y is equal to 0. You equate to 2. Here there's nothing. Here there's nothing. We go back. We go to this one. Minus 4,5x plus y is equal to what? Is equal to 120. These two are the same, so there's no effect there. Then y is equal to nb, in this case, on this part, y and nb. So you're saying y is equal to nb. So by calculating the value of y, we are calculating the speed of the arm B. So this is the information that we have. So meaning to say we can play around with these two equations in order for us to calculate y. All right, so let's say this is our first equation. This is our second equation. Since I want to calculate y, I have to focus on y. I have to focus on y in this case. Since I am to calculate the value of what? Since I am to calculate the value of y, I can focus on y. So in this case, I can make x the subject. That means from equation 1. So from equation 1, if we make x the subject, what's going to happen here? If we make x the subject, it means that x is equal to transpose y to this side. It becomes a negative, so that's minus y. So with this value, I can substitute minus y where there is x. X is minus y. So where there is x in equation 2, I'm going to substitute minus y. So it's minus 4,5x, which is our x. It's minus y in this case, plus y that is already there. This is supposed to give us 120 in this case. We are supposed to obtain 120 from this part. So if you combine minus 4,5 times minus y, negative is going to be a positive. 4,5y plus y, which is 1y, is equal to 120. So this is same as 1y. So you add 4,5 plus 1, which is going to be 5,5. So 5,5y is equal to 120. Divide by 5,5. What are we going to obtain at the end is the value of y, which is going to be 21, something in this case, which is a positive. So it's going to be 21,818. This is the value of y. But remember, we are saying the speed of B is equal to y. So therefore, it means the speed of B, which is our arm, is going to be 21,818 revs per minute. A positive means it's a clockwise. So the direction in this case, it means we are dealing with a clockwise. All right. So that is how you answer these questions, just like that. So we have answered the question 2 now. We have answered 2 questions using the same table, but you relate to the information about that question. The information about that question, we are talking about question number 1. You relate your table to the information that you were given on question number 1. This was the information on question number 1. So you take your information, equate to that part alone. When you answer the information about question 2, you are now equating your xy to the information about the question 2, whereby this condition is the one that you are given from the question. The first stage, the second stage, it's a fixed part that you need to know. You fix the arm, you rotate the annulus, or you rotate the largest gear wheel. The second part, you multiply by x and you add y. So it's a fixed part that you're supposed to know. Then from there, by solving your simultaneous equation, or by solving for x and y, you can calculate whatever speed that you're supposed to calculate. Here, we're dealing with the speed on G. Here, we're dealing with the speed on B. This is our first question. This is the second question. So if we can understand this, I think we can answer as much questions as we can on our epicyclic gear trains. So we shall try by all means to work with the many questions, as much questions as we can. Let us know the question papers that we can work with. There are so many questions or so many question papers that we have. So let us try to add as much questions so that we can work on them, revise on them. But for now, that's it, guys, from MECHANOTECHNICS African Motives. Till we meet again.